Rate law is a basic knowledge among chemistry students. Basically, in rate law, there are several factors that affecting the rate of reaction. Those factors are concentration, temperature, a different reactants, and surface area. In this video, we are going to focus on the rate of reaction between vinegar and sodium bicarbonate according to those factors that has been stated just now. But before that, we would like to introduce ourselves. This is Nur Lisa Hani. Then she is Siti Suhada. Next is Fatin Amira. This one is Nur Fahana. And I am Nurliana Atira. So let's get started, shall we?
Okay, firstly I would like to introduce to you guys what is vinegar and sodium bicarbonate. Those are the chemicals that we are going to use throughout this video, as stated in the question for this assignment. In this picture, this is vinegar. It is also called as acetic acid. Acetic acid is in the IUPAC name. Okay, now I will draw for you the structure of this acetic acid. The molecular formula is C2H4O2 or CH3COOH. Next chemical is sodium bicarbonate. Usually the name is also known as baking powder. The molecular formula is NaHCO3 or CHNaO3. Now this is the drawing of the structure for sodium bicarbonate. So there is some of general knowledge about our chemicals used in this video relating to rate law.
Okay, I am Fatin. I will tell you about what is rate law.
In studying in chemical reaction, it is important to consider not only the chemical properties of the reactants, but also the conditions under which the chemical occurs. The rate law is express the mathematical relationship between the rate of reactant and concentration of reactant. Here is the formula.
Okay, enough with the introduction. Let me start explaining about those factors. The first factor is the concentration. What do you guys know about concentration? Well, Liana will show you guys what concentration will do to the rate law.
In concentration, the simple experiment is there are two beaker, which is inside it has different concentration of the vinegar, while the mass of the baking powder is the same. Beaker A and B contain 1 gram of baking powder. Then, Beaker A has higher concentration of vinegar than in Beaker B. The bubble in Beaker A has more than bubbles in Beaker B. This shows the different reaction in different concentration.
So, that is all about concentration. Next, we proceed to the next factor. What is the next factor, guys? Come on guys and guess. I will count 1, 2, 3. You shout it out, okay? Okay, we start counting. 1, 2, 3. Well, I will tell you guys. Okay, the factor is the temperature, which is Lisa will show it to you guys what temperature will do to rate law. Okay, let's start.
In this experiments there are 4 different temperature. The mass of vinegar and volume of baking powder is constant. The result is different when the vinegar is poured into the beaker that contains baking powder. Therefore, at higher temperatures, the baking soda dissolved faster. This proves that at higher temperatures it has more kinetic energy, allowing the vinegar solvent to collide with undissolved baking soda solute particles more frequently.
Wow! Now we already know 2 factors that relating to this rate law. Okay guys, how many factors that we still not explain left? Well, there is 2 more factors left. Wow, you guys are awesome! Now, let's pay attention to the next factor that Siti will show to you guys what different reactant will do to rate law.
Okay, thank you Fatin. Well guys, may I start? Here's the idea.
The nature of reactants refers to the physical state of elements or compound that are taking part in a chemical reaction. In yield maximization, since from the concept of nature of reactants, gas tend to react faster than liquid and liquids to solids.
Phew, okay, this is the last factor that related to this law. What is the factor? Well, the last factor is surface area. This part Anna will explain this by myself. Let's start.
The larger chip of CaCO3 has small surface area compared to powder CaCO3, which have higher surface area. According to theory, the greater surface area allows more collisions to happen at per unit time. Therefore, the time sodium bicarbonate uses to dissolve in vinegar is decreasing. As the surface area of sodium bicarbonate increasing,